Hello everybody. In this video we will discuss about ether functional group. So ether functional group, just like alcohol, it has oxygens. The only difference is on this oxygen on either side, well I should say on both sides, we got carbon chain. So there is carbon chain on both sides. However, in alcohol there is a hydrogen on one side, and that's going to cause a major physical property change because of that property. We know that your alcohol can form hydrogen bond. So alcohol can make hydrogen bond, right? But here ether cannot make the hydrogen bond. So as a result, we know that hydrogen bond is a stronger intermolecular force. So this is a stronger intermolecular force, stronger intermolecular force. So in general, so if something you have strong force of attraction between the molecules, they should have higher boiling point. But in ether, you don't see hydrogen bond, so there is no hydrogen bond. But the only type of interactions that you will see is dipole moment. So dipole interactions. So dipole interactions, which is weaker. So dipole interactions is weaker than our hydrogen bond. Okay, so this is the dipole interactions is a weaker force than the hydrogen bond, but this is a stronger force, stronger intermolecular force than our van der Waals force or London dispersion force, right? So if we are comparing against London dispersion force, then this is stronger. So let's try to compare this. So let's say you have a scenario where you have the structural isomers like this, CH3 CH2OH, that's our ethanol, versus CH3OCH3. So both have the same formula. Who is going to have higher boiling point? Well, of course, the ethanol going to have higher boiling point. Why? Because ethanol can make hydrogen bond on top of all the other interactions. But here, the strongest force of attraction that exists in ether is going to be your dipole interactions. That's the strongest force of attraction that exists. So hence, this one will have lower boiling point. All right. So let's do another of this type of example. Let's say we talk about this ether. I will explain the nomenclature in a second. So let's say we have this versus a propane. So who do we think will have the higher boiling point? Well, the answer is this. So this will have higher boiling point. The question is why? The strongest force of attraction that exists in ether, so this is a separate problem. So the strongest force that exists in ether is dipole interactions, right? So that's the dipole interactions. But in propane, the strongest force of interaction that exists is our London dispersion force. So this is the strongest force, and we know that London dispersion force is the weakest one. So this is gonna be lower boiling point. So we can compare against different type of functional groups to figure out what kind of boiling point you will have. All right, so let's look at the nomenclatures. Okay, so how would you name them? Well, let's start with the common names for ether. So common names. It's kind of the way we write this is a you write this alkyl ether. So this is the style. So this is the common name style you will use. So what do I mean by alkyl ether? Okay, so let's look at here. So you have oxygen. On one side, you're going to have a carbon chains, right? So in this case, so there are two carbon chain on either side. So this is one carbon chain. This is another carbon chain. So what is this carbon chain? This side is metal. This side is metal. So we can call it metal ether, but instead of calling metal ether, we're gonna call this dimethyl ether. Okay, so that's the name, dimethyl ether. What if you got on one side CH3, but other side you got CH2, CH3. So in this case, the group that we have here is metal. The group we have on the other side is ethyl, because it has two carbon atoms, right? Two carbon atoms is ethyl. And then you go with alphabetical. So E comes before. So we're going to call it ethyl methyl ether. And that's how you name them. So if you have this CH2, CH3, CH2, CH3, then this group is our ethyl. This group is also ethyl. And this group is also ethyl. So instead of calling ethyl ether, we can call it diethyl ether. So this is a common solvent we use in many of the organic reactions, you will see. So that's our diethyl ethers. All right, so let's go with the systematic name. So how would you systematically name these ether? So systematic name of ether. Okay, the style we use is gonna be alkoxy alkane. So this side here is gonna be your so this is gonna be parent chain. Usually the longest chain is gonna be your parent chains. So parent chains, usually the longer one, we're gonna call it longer, or the bigger one is gonna be your parent, and the other side will act as a substituent. And it will make a lot more sense. So let's try to do this one here. This one would make sense. So what is the name? So this one we had ethyl methyl ether, right? So I will draw the same thing. Okay, I will draw this side, CH2, CH3, and CH3. Okay, so which side is longer? So you gotta look at oxygen. This is at the middle. On this side, we got carbon chain. This side, we got carbon chain. Which side is longer? The longer side is this one. So this one is your longer side. So this one is your longer. So this would be your parent. So this would be your parent. How many carbon atom here? It has two carbon atom. If you have two carbon atom, what is the name? Two is eth. So we're gonna call it ethane, not ethane, ethane. Okay, so ethane right there. And on this side, so this is your shorter, the shorter portions, right? So this is your shorter. So shorter is gonna be alkoxy, and this portion has how many carbon atoms? So this is the shorter side, and it has how many chain? One carbon atom. And one carbon atom means meth, and then meth is followed by oxy, methoxyethane. So the way you write the name is gonna be methoxyethane. Okay, ethane has only two substituents, so it's always gonna be one, but you will see in a second, you gotta number them properly. Okay, so let's do one more example and then it will make a lot more sense. So let's say you have another example. So let's say you have oxygens, then CH2, CH3, and then you got CH2, no, CH3, CH2, oh, this would be CH, CH2, CH3. Okay, so how would you name this one? So you have a functional group oxygens and there is a carbon chain. So this is an ether. So this side is obviously look shorter. Okay, so how many, so this side is shorter. So shorter means this would act as a substituent. And how many carbon atom this one has? This one has 2 carbon atoms. So if you have 2 carbon atom, what is the number? What is the name? We use eth. So if you have forgotten, 1 is meth, 2 is, okay, 1 is meth, 2 is eth, 3 is prop, 4 is but. So those are the name you're gonna add to this. 5 is pent, 6 is hex, 7 is hept, 8 is oct, 9 is non, and 10 is dec. Okay, so it's gonna be 2 carbon atoms. So 2 carbon atom, and how do we write the substituent? So you just add oxy, ethoxy. Okay, let's look at here the parent. So parent here is gonna be, so this one is longer. So this one would be parent. Okay, and what is the parent name here? So it has 4 carbon atom. 4 carbon atom means it's an alkane. So it's gonna be butane. All right, so we got our name. So ethoxy and parent is butane. Last thing we gotta do is number them. So in the numbering always has to be with the parent chains, right? So where exactly this pink group is attached? Well, you gotta give the minimum possible number. So it's gonna be number 1, 2, 3, 4. You could have number on the opposite side. So when you name your parent, always number end to end. Like don't start here. Like I have seen a lot of students start like this, 1, 2, 3. No, you're gonna number end to end and find the way that's gonna give you the lowest possible number. You can number like this, 1, 2, 3, 4, or you can number 1, 2, 3, 4, but it has to be end to end. So now question is which one? So on this side here, you are giving number 2 for our substituent here, number 2 for our substituent here, but on this side you are giving 3. So obviously you're going to be picking this as an answers. All right, so let's erase this. So it's going to be 2 ethoxy butane. Okay, that's how you name our ether. All right, let's stop here.